Hi, everybody. I wanted to take a few minutes to talk about some of the main terms and concepts that we've been discussing so far in this unit. Right now we're on Unit 1, which is all about matter and change. So we're going to talk about things that relate to matter and change. The first is chemistry. So the definition of chemistry is really important for you to understand because while you're taking chemistry class this year. So I wanted to take a few minutes to talk about some of the key terms in the definition and give us all a better understanding of what we're going to be studying. So chemistry is the study of the composition, structure, and properties of matter and the changes that matter undergoes. The terms composition, structure, and properties are really important in understanding what this definition means. So the composition is what something is made of. The structure is how it's made or how it's put together, and the properties describe how something behaves or acts. Now, matter, which is the overarching theme of this whole unit on matter and change, is something that we are going to spend a few minutes discussing. I want you to write down some of these definitions or type them, and I want you to list some examples of the things that I'm asking examples for. So matter is anything that has mass and volume, and it has to have both mass and volume. Volume is the space that something occupies. So matter is anything that has mass and takes up space or volume. Matter can be broken up into two main subgroups, mixtures and pure substances. So the thing that separates a mixture from a pure substance is that mixtures can easily be broken down or taken apart, whereas pure substances are very difficult to break down any further. Now, pure substances are going to be things like elements and compounds. Elements are things that we find on the periodic table of elements, which is something that we're going to be studying a lot in this unit and throughout the year. Compounds are made up of elements. So we call elements the building blocks of matter because everything is composed of elements. Everything can be further broken down until you get to those building blocks or elements. Compounds are elements that are connected to one another with bonds. And we're going to be talking a lot about bonds this year, but not quite yet. So it's important to understand right now that bonds are really strong attractions and they're really hard to break. Now, mixtures can be broken down into two groups as well. Heterogeneous mixtures and homogeneous mixtures. Heterogeneous mixtures are mixtures that you can identify the different components of just by looking at the mixture. Whereas homogeneous mixtures or solutions look uniform in consistency, in color. It looks like one substance, but it's actually two. So I'm going to give you a minute to think of some examples of each of those four subgroups at the bottom of this chart. Heterogeneous mixtures, homogeneous mixtures, elements, and compounds. Now I'm going to give you my examples of each of these, and you can see how they compare with what you came up with. So an example of an element, we're going to start with elements because they're, the building blocks of everything, is carbon. Carbon is my favorite element. You'll learn a lot more about why as we go throughout the school year together. An example of a compound is water, H2O, or table salt, which we just call salt, but really salt is a larger group of substances. And we'll talk more about those later as well. Well, salt's chemical name is sodium chloride. An example of a heterogeneous mixture would be something like trail mix or pasta salad or cereal. Things that when you look, you can identify the different pieces of that substance, and you can easily identify them from one another. Homogeneous mixtures or solutions, remember, you look at them and they don't look like more than one substance, but they actually are. Those would be things like salt water or iced tea, for example. Another type of solution or homogeneous mixture would actually be air. What we breathe, the air around us. We look at the air and we actually don't see anything. But if we were to look at it at the submicroscopic level, at the elemental level, we would find lots of different substances in it. All right, so moving on, let's talk about properties and changes. These are ways that we can describe different substances. So properties can be broken up into two primary groups, the physical and chemical properties, and then the qualitative and quantitative properties. Physical properties are things that we can identify just by observing something. So we can see it or feel it or smell it. And we aren't changing the substance by observing it in that way. Chemical properties are the ability of a substance to change and to change into something else. So these would be things like flammability. Flammability means the ability to catch on fire. So if we were to light something on fire, it would end up as something different than it started, and it would have undergone a chemical change. The other subgroup of properties is qualitative and quantitative properties. Qualitative properties are things that we can observe that do not depend on how much of a substance we have. Things like color or texture or shape, those would all be qualitative properties. And then quantitative properties would be things that have to be measured or depend on the amount. So something like mass would be a quantitative property. Another example of a quantitative property would be volume. That would be something that you would measure. Methods of separation. So we have already explored or are beginning to explore one method of separation, which is chromatography. Chromatography, you will soon find, is a way that we can separate different types of mixtures like inks and pigments. I want to give you all an opportunity to come up with a few more examples of how you can separate a mixture. So I'm going to let you fill in your own answers here, and then I'll give you a few examples of mine so that you can add them to the list. Here are a few more examples of how we can separate mixtures that you can add to your own list. And maybe you came up with some of these on your own. So fill those in, add them to your list, and we will explore more of these a little bit later on. All right, so that's going to end our discussion for today, but we will pick up there with the chromatography lab when we discuss it together in class.